Then, in the late 1920s, all that changed. During those years, physicists developed a new theory called quantum mechanics, and it was able to describe the microscopic realm with great success. But here's the thing. Quantum mechanics was so radical a theory that it completely shattered all previous ways of looking at the universe.
Einsteins teorier kräver att universum är välordnat och förutsägbart. Men Niels Bohr och hans kollegor hävdade att i atomernas och partiklarnas värld är allt chansartat. På kvantnivå är ingenting givet. Det bästa man kan göra enligt kvantmekaniken är att förutsäga sannolikheten för olika händelser. Den originella idén öppnade dörren till en ny och förvirrande bild av verkligheten. Det man såg var så förvirrande att om kvantmekanikens motsägelsefulla företeelser hade varit synliga, som de är här på Quantum Café, så hade man kanske trott att man hade blivit tokig.
The laws in the quantum world are very different from the laws that we are used to. Our daily experiences are totally different from anything that you would see in the quantum world. The quantum world is crazy. It's probably the best way to put it. It's a crazy world.
For nearly 80 years, quantum mechanics has successfully claimed that the strange and bizarre are typical of how our universe actually behaves on extremely small scales.
I vår vardagsverklighet ser vi inte paradoxerna i kvantmekanikens mikrovärld.
But here in the Quantum Café, big, everyday things sometimes behave as if they were microscopically tiny. And no matter how many times I come here, I never seem to get used to it. I'll have an orange juice, please.
I'll try.
I'll try, she says. You see, they're not used to people placing definite orders here in the Quantum Café because here, everything is ruled by chance. While I'd like an orange juice, there's only a particular probability that I'll actually get one. And there's no reason to be disappointed with one particular outcome or another because quantum mechanics suggests that each of the possibilities, like getting a yellow juice or a red juice, may actually happen. They just happen to happen in universes that are parallel to ours, universes that seem as real to their inhabitants as our universe seems to us.
If there are 1,000 possibilities and quantum mechanics cannot with certainty say which of the 1,000 it will be, then all 1,000 will happen. Yeah, you can laugh at it and say, well, that has to be wrong. But there are so many other things in physics which at the time that people came up with had to be wrong, but it wasn't. You have to be a little careful, I think, before you say this is clearly wrong.
Enligt kvantmekaniken är det också i vår egen värld sannolikt att sånt som vi tror är omöjligt faktiskt kan hända. Det finns till exempel en viss liten sannolikhet för att partiklar kan passera genom väggar eller hinder som verkar ogenomträngliga för oss.
There's even a chance that I could pass through something solid, like a wall. Now, quantum calculations do show that the probability for this to happen in the everyday world is so small that I'd need to continue walking into the wall for nearly an eternity before having a reasonable chance of succeeding. But here, these kind of things happen all the time.
You have to learn to abandon those assumptions that you have about the world in order to understand quantum mechanics. In my gut, in my belly, do I feel like I have a deep intuitive understanding of quantum mechanics? No.
Einstein hade inget till övers för kvantmekaniken. Han förlorade aldrig tron på att universum uppför sig på ett bestämt och förutsägbart sätt. Föreställningen att man bara kan beräkna sannolikheten för olika händelser var han djupt skeptisk mot.
Quantum mechanics says that you can't know for certain the outcome of any experiment. You can only assign a certain probability to the outcome of any experiment. And this Einstein disliked intensely. He used to say, God does not throw dice.
Men experiment efter experiment visade att Einstein hade fel och att kvantmekaniken verkligen beskriver hur världen fungerar på atomernas nivå.
So quantum mechanics is not a luxury, something that you can do without. I mean, why is water the way it is? Why does light go straight through water? Why is it transparent? Why are other things not transparent? How do molecules form? Why are they reacting the way they react? The moment that you want to understand anything at an atomic level, as non-intuitive as it is, at that moment you can only make progress with quantum mechanics.